Hello guys, how are you today? So today I'll be explaining the math geometry course practice of section 5.5, which is our last section for the periodic. So let us start with the first question. Fill in the blank. A container has a surface area of 2000 centimeters squared and the capacity of 40 liters. Whenever they say capacity, it means volume. Okay? The surface area of a similar container which has a capacity of 5 liters, again, this means volume, is equal to, they need us to find the surface area of a similar container. Whenever they use the word or term similar, what does it mean? It means that we have to use the ratios. And what are the ratios? The ratios are very simply side 1 over side 2 is equal to K, constant. Area 1 over area 2 is equal to K squared, constant squared. And then finally, volume 1 over volume 2 is equal to K cubed, or constant cubed. So if we apply this over here, we will be able to find the surface area of the similar container. Very simply, we can find what? We can find the K cubed because we are given volume 1 and volume 2. So volume 1 over volume 2, it is equal to 40 over 5, which is equal to 8. So 8 is equal to K cubed. If you want to find the answer, you could either do it mentally, which is very easy. It's going to be 2. So that means K is going to be equal to 2. Or if you don't know how to find it, if it's a big number, you can do shift. And then you click on the radical, you are going to get the third root or the cube root. And then you put the number 8, you are going to get 2. Okay, so now that we have the value constant K, we can now apply the other equation, which is area 1 over area 2. So we have area 1 to be 2000 centimeter cubed over area 2. It is equal to what? To the constant squared. So the constant, it is 2. We are going to square it. So it becomes 2000 over area 2 is equal to 4. Then after solving it a little bit more, you are going to get that area 2 is equal to 2000 divided by 4, which is then 500 centimeter squared. And just like that, we finished solving the first question. We will move on to the second question, which is question number 2. A sphere has a volume of 36 pi meter cubed. Keep this in mind, and you should know that the volume of any sphere, it is 4 over 3 pi r to the power of 3. Keep this in mind, okay? Now they need us to find what? The radius of the sphere. We know that the volume, it is 36 pi, and the volume of any sphere, it is 4 over 3 pi r to the power of 3. So if you make them equal to each other, you will be able to find the value of r. Okay? So cancel pi and pi. Now you have 36 is equal to 4 over 3 r to the power of 3. Move this to the other side. You are then gonna get that r to the power of 3 is equal to 27. Okay, and again, you could either do it mentally. It's easy. It's gonna be 3. You're gonna get that r is 3. Or if you can't do it mentally, you do shift radical. You're gonna get the cube root. You will put the number, which is 27, and you will get the answer 3. So we found the radius of the sphere being equal to 3 meters. Now we move on to the surface area of the sphere. The surface area of any sphere, it is 4 pi r squared. Okay, we have the radius, so we can find it. It's 4 times pi times 3 squared. Put it on the calculator, and you are gonna get 36 pi. We move on to part B. Given a sphere whose radius is double the radius of the sphere given in part A, the surface area of the larger sphere. Okay, again, here they did not use the term similarity, but what we could do is we could infer from what they are saying a similarity. So the radius of this first sphere is 3. They said a sphere whose radius is double, so now it's 3 times 2, which is 6 meter. Now the sphere has a radius of 6 meter. They will need us to find its surface area. You could do it in many ways. You know that the surface area, its equation is 4 pi r squared, you could put it on the calculator and you would get 144 pi. This is one of the ways to do it, but how they want us to do it is using the similarity ratios. So very simply, you have the radius, which is the side. So radius 1, so let's do side 1 over side 2 is equal to the constant. So radius 1 is side 1, radius 2 is side 2, it's equal to the constant, which is 1 over 2. Now they need us to find the surface area. We know that area 1 over area 2 is equal to the constant squared. So area 1, it is 36 pi. Over area 2, it's equal to the constant squared. So square this, you are gonna get 1 over 4. Then you do cross multiplication. You are gonna get that area 2 is equal to 144 pi. As you can see, both of them are the same answer. We'll move on to question number 3. Here, this is also a nice question. A container has a surface area of 900 centimeters squared and a capacity, meaning volume, of 54 liters. The surface area of a similar container which has a capacity or volume of 2 liters is equal to, very simply, as we said before, side 1 over side 2 equal k, constant. Area 1 over area 2 equal k squared, constant squared. And then volume 1 over volume 2 equals k cubed or constant cubed. Now, we have volume 1 and volume 2, so we can find the constant cubed. So very simply, it's going to be 54 over 2. You're going to get constant cubed, which is then 27. So we can find the value of the constant by using your calculator, or if you know it directly, it is going to be 3. Okay? Now, they need us to find the surface area of a similar container. This is area 1. They need us to find area 2. So area 1 over area 2 equal constant squared. So 900 over area 2 is equal to the constant 3 squared. So 3 squared is 9. Then after solving, you will get A2 is 900 over 9, which is then 100. So very simply, area 2 is going to be 100 centimeter squared. We move on to question number 4. This is also a very nice question. A sphere has a volume of 972 pi meter cubed. We know that the volume of any sphere, it is 4 over 3 pi r to the power of 3. So we can find the radius of the sphere very simply by equating them, making them equal. You cancel this and this, you get 972 is equal to 4 over 3 r to the power of 3. Then you move this to the other side, you're going to get 972 times 3 divided by 4. Then you are going to get that r cubed is equal to 729. And again, you could use your calculator or you could do it mentally, and you're going to get that r is 9. Okay, so now we know that the radius of the sphere is 9 meters. The surface area of the sphere, they need us to find the surface area of the sphere. We know that the surface area of any sphere, it is 4 pi r squared. Okay, so you take the radius, you put it, so it's gonna be 4 times pi times the radius, which is 9 squared. You put it on your calculator, you are gonna get 324 pi. So now we have the radius to be 9 meters and the surface area of the sphere to be 324 pi meter squared. So given a sphere whose radius is double the radius, that means if the radius, which is side 1, is equal to 9, then side 2 is gonna be double, so 2 times 9, which is 18. They need us to find the surface area of the larger sphere. Again, you can do this in many ways. Surface area of any sphere is 4 pi r squared, so you could do 4 times pi times 18 squared, and you would get the same answer, which is 1296 pi. Or you could use the ratios of similarity. So you have side 1, which is 9, and side 2, which is 18. It's equal to the constant, which is 1 over 2. Now, area 1, which is 324 pi, over area 2 is equal to the constant squared, which becomes 1 over 4. You do cross multiplication, you get area 2 is equal to 1296 pi. So very simply, area 2, and this is going to be 1296 pi meter squared. We'll move on to question number 5. This is a very nice question. It's direct to the point. Cone A is similar to cone B. Cone A has a height of 12 centimeter and a radius of 6. Cone B has a height 72 and a radius of 36. The linear scale, whenever they say linear scale, that means it's the constant K. When they say area scale, sorry for the bad writing, area scale, it is what? It is constant K squared. If they say volume scale, it is constant K cubed. That's it, very simply. Okay, so since they are asking for a linear scale, it is the constant K. So you're gonna choose any two sides. You could choose the height, so 72 over 12, but it's also gonna be equal to the radius, so 36 over 6. Very simply, it's side 1 over side 2 equals side 1 over side 2 because of similarity, and then you're gonna get the constant, which is gonna be 6. So very simply, the constant over here is 6. We move on to question number 6. Now here we have sphere A is similar to sphere B. Sphere A has a volume of 150 centimeter cubed. Sphere B has a volume of 600 centimeter cubed. They need the volume scale. Very simply, the volume scale, as we said, it is what? It is the constant K cubed, or very simply the ratio of volume. So it's gonna be volume 1, which is 600 centimeter cubed, over volume 2, which is 150 centimeter cubed. You are gonna get it 4. Now, something I did not pay attention to in the previous question, question 5. Pay attention here. K is greater than 1, so you could do 150 over 600, but you're gonna get 1 over 4. 1 over 4, it's definitely less than 1. So if they need K greater than 1, you are gonna take the bigger number, which is 4. So let's submit, and hopefully there are no mistakes. And thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.